This video is going to continue our exploration of combining probabilities, but focusing sort of on or probabilities, or either or probabilities, you'll sometimes hear them called. And a great way to visualize this is sort of going back to our Venn diagrams. So we're going to look at a few examples with Venn diagrams for this one. And there's sort of two situations in which we have or probability. We have what we would call non-overlapping events and then overlapping events. Well, with non-overlapping events, the first event and the second event have nothing in common. So notice here with our flipping a coin, there is no overlap. There's no times that both event A and event B occur simultaneously. Nope, doesn't happen. Versus on overlapping events, so down here we have overlapping events. If I'm drawing cards out of a deck and I'm comparing the type of card to the suit, there's a card that's both a queen and a club. So there's what we call overlap, and how we tackle that probability is going to be a little bit different. Now, when it comes to or probability, sometimes you sort of want to keep in your mind, we're going to be adding values. And if you're dying for a formula, because some of us like formulas, and I Google or probability, I would get a formula of, so we'd have the probability of A or B, and it would just be the probability of A plus the probability of B. Now, what you're going to find when I go through and do these examples is I don't actually use this formula. I go back to sort of the theoretical probability formula, and I just sort of look for numbers of outcomes. But just in case, I like to give you formulas in case you want to use them. But we're going to look at a situation. So Mr. Grosetta has a bag of candy. It contains 3 M&Ms, 5 Snickers, 4 Twix bars, and 16 Dum Dums. He randomly puts his hand into the bag. That's supposed to be bag, not back. And draws out a piece of candy. What's the probability that he picks an M&M or a Snickers? Well, first off, how much candy is in the bag? So if I total up the amount of candy in the bag, I have 3 M&Ms plus 5 Snickers plus 4 Twix plus 16 Dum Dums for a total of 28 pieces of candy. Now, when we talk about or probability, that means this event has happened if I go in the bag. If he goes in the bag, he picks out an M&M. This event would also happen if he goes in the bag and draws out a Snickers. Now, there's no way that in a single draw, it could be both a Snickers and an M&M, which is why we call this non-overlapping. So in this case, though, if I'm thinking, what are the chances of that M&M or, oops, I should probably use or there, or Snickers. Well, there are 3 M&Ms and 5 Snickers, so there are 8 of those 28 pieces of candy are the candy I'm looking for. Usually M&Ms or Snickers are my favorites, so I'm really hoping that one of those come out. So then if I say the probability of getting, M or S, and I'm, abbreviating here, there are 8 possibilities out of those 28. And that would be my probability. And I could turn that into a decimal, and the decimal would be 0.85. Oops, nope. It would not be that. It would be 2857. And if I wanted to round that to 3 decimal places, that 7 would mean that 5. We're actually going to turn that into a 6, and there's my probability. Now, how does that connect to this addition formula? If I sort of said, what is the probability of drawing out event A? That would be getting an M&M. So that would be 3 out of 28. And then I'd add that to the probability of getting a Snickers, which is 5 out of 28. And believe it or not, when I add these two fractions together, I'd get 8 out of 28, which is the same thing I did just by sort of reasoning how many Snickers or M&Ms are there, how many total candies, there's my probability. And so notice I'm sort of going straight to that theoretical probability formula and not stressing a ton about the specific formula for or probability. And you're going to see this with a lot of the ones we're now moving into. All right, so overlapping events. the thing about overlapping events is we can't simply add because we have that overlap. So like in this case, if I wanted to know the likelihood of drawing out a queen or a club, there is that one card that is both a queen and a club. And so that changes sort of the addition going on. And so sometimes, we do have formulas here. And so I could go through and say, if I Google this, what's going to come out, and I look, Google or probability, is you'll notice the formula starts the same, but then you're going to see a minus P, A, and B. And you're like, what is this? Well, this right here is saying we need to take out the overlap. Because if we counted the number of queens, there are 4. And then if we went through and we counted the number of clubs, that would be 13. But what happened there is we counted this one in the middle twice. So we would need to take that overlap out. Yes, I can use the formula. I'm going to just count up numbers like I did on the last one. It's a personal preference. I tend to like it that way. I will show you with the formula second, but I want to show you the ease of just reasoning through with numbers first, because if you focus a little less on, well, what method is this and what formula do I have to use in just general, like how many times did that event happen, how many total possible outcomes, it's a lot simpler to sort of focus on. So we're going to go back to a Venn diagram from one of the earlier lessons. So we have a Venn diagram here that show the results of a survey in which people were asked what type of board games they like to play. If you were to randomly select someone from this group, what is the probability that they like either Settlers of Catan or Pandemic? So if you remember back when we were sort of highlighting, or relationships, we're looking for everything in this circle and in this circle. And we don't want to double count the overlap. So if I'm, thinking here, okay, the number of people who like Settlers or Pandemic, I can find that by just adding all the numbers in yellow. So 13 plus 5 plus 35 plus 10 plus 8, and I would get 71 people like either Settlers or Pandemic. And then if I go how many total people were surveyed, I'd take that 71 and then add 17 and 2 to it because those are on the outside, and I'd get 90 total people that were surveyed. All right, so if I want the probability of Settlers or Pandemic, that would be 71 out of 90 of the people, which was about 0.789 or 78.9% of them. So notice, that was a straight, I'm just, adding I have to add my numbers up anyways because I'm, I have my different spaces on my Venn diagram. And so this sort of then builds into the interpreting the diagram like we were doing last lesson, and then adds in this extra step of how do I take this and then find a probability with it. That's why we spent so much time on Venn diagrams, so that we can do stuff like this. Now, if I did want to use the formula, I could here. And what you'd end up doing is I'd say, okay, well, the probability of S would be the probability of, and then I have the probability of, Pandemic, and then I take out the overlap. So in this case, the probability of Settlers of Catan would be the 8 plus 10 plus, so the 8 plus 10 plus 35, which would be 53 out of the 90. And then the Pandemic would be, 13 plus 5 plus 35, which would be also weirdly 53. And then I'd minus out the overlap, which is just that 35. And guess what? Believe it or not, you would still get 71 out of 90. It wouldn't change. I think it's a little more complicated. I like sort of the reasoning like I did up front. I think that it's a little bit sort of simpler. And then I don't have to stress so much of which formula is it? Oh my goodness, I can't remember. But here are some examples of OR probability, one with non-overlapping events and one with overlapping events.